So, welcome back to another episode of the Func Prog podcast with me, Christopher, and today I have with me Adam Tornhill. Welcome to the podcast, Adam.
Thanks a lot, Christopher. Really good to be here.
Yes, I'm really happy to have you. It feels like we've had I always feel like this show kind of has kind of like a static typing bias, but today we're going to talk a lot about Clojure, so hopefully we can make it a bit more like, fair and balanced. So it's not only like statically typed functional programming. But first, can you tell the audience a little bit about who you are, like your background and what you're doing now?
Yeah, sure, I'd be happy to. So I'm Adam, I'm based in Sweden. I'm a programmer. I've been a software developer for many, many years, been working for almost 3 decades in the industry. I'm an electrical engineer by training, but I have my second degree in psychology, and that combination has influenced a lot of the work I've been doing over the past decade.
Oh, I didn't know that. The psychology thing, that was news to me.
Yeah, that's where all the strange CodeScene stuff came from.
Yeah, we'll have to talk about that later. But okay, so you were trained as an electrical engineer, but at some point you sort of switched into computer science, or?
Yeah, I was always more interested. I grew up with the Commodore 64 in the 1980s, so that's where I learned to program. I was always super interested in programming, but somehow I never understood as a kid that I could actually get a job in that discipline. So I studied electrical engineering, but I've never worked as an electrical engineer. I went directly to software and never looked back.
Okay. And now you are, I guess most of your time is taken up by your company, right?
Yes.
CodeScene,
yes.
Yeah, can you tell me a bit more about what is CodeScene?
So CodeScene is a software analysis tool, and it's a very different tool compared to the regular linters and static analysis tools that you have. Because what CodeScene does is that it's completely automated. It generates a complete visualization of your whole code base. And then it points out where the good parts are and where the bad parts are. And we also prioritize based on impact. So we're not just looking at the source code, we're also looking at how do you and your organization interact with the code. Where is the development work actually happening? And that means we can prioritize the technical debt that impacts you the most, which is always complicated code that you also have to work with often. So it's really an intersection of code and people. That's CodeScene.
So, and what is technical debt?
Yeah, that should be a simple question, but it's not really, because technical debt in the original sense, I mean, we have drifted far from that original definition. So the definition I tend to use is that technical debt is code that's more complicated than it should be.
And is that sort of what CodeScene detects as well? Like, is that what? How does CodeScene reason about technical debt?
Yeah, so CodeScene reasons about technical debt on 2 different dimensions. The first is the quality aspect. We need to be able to tell if one piece of code is objectively good or objectively bad, right? And everything in between, of course. So for that, we use a metric that we call code health. It's a CodeScene innovation that I've been working on for the past, I think, 8 years or something like that. So that one analyzes the code and looks for certain patterns that make the code hard to understand for a human. So it could be, for example, low cohesion. You have stuffed too many responsibilities into a module, right? So now it's hard to reason about because there are so many business rules there. It could also be patterns in how we implement the code, for example, deep nested logic and all that nasty stuff, copy-pasted code. 25 factors like that. We weight them together, and then we can categorize a piece of code as being in either the healthy space or the unhealthy space. But the second thing we do, the second dimension, is relevance. Because you can have bad code that's been stable in production for 5 years that you never need to touch, it just works. So it's good to know that it's there, right? That there is a potential problem, but it's probably not going to impact you right now. It's not holding you back. So that's why we need this second dimension that we call hotspots, developer hotspots. So what we do here is that we look at version control data and see where is the development work actually happening and how is it shifting over time. And when you see an intersection of a highly complicated piece of code that's being worked on frequently, then we know based on our research that this is very likely to be super wasteful technical debt, and we can flag it as a prioritized improvement.
Okay, so you can see that, like, okay, this code is like it's both problematic and people are actually working with this thing like continuously. So then
exactly.
that makes it a hotspot. And like the code health thing, is it kind of like, does it kind of create a call graph of different, like how the different modules interact, or how does the like static analysis thing work?
Well, let me share a little bit about the background. So originally, when I founded CodeScene, I was mostly interested in like the behavioral aspects of software development. So like, how do people collaborate? Where are we working over time? But I kind of quickly figured out that I actually need a quality dimension too, because you can do a lot of work in parts of the code that are healthy, that are good. And when that happens, you're in a very good place, right? That's where you want to be. So I was looking to use existing metrics because there are a lot of code complexity metrics in the industry. But when I started to look at the research behind them, I kind of found that none of them really works, in the sense that they don't have much predictive value, right?
Oh, okay.
So if you look at something like, I don't know, like the most popular metric, cyclomatic complexity, it's been around since the 1970s. And if you look at the research on it, you will see that the moment you start to control for the number of lines of code, this more elaborate metric of cyclomatic complexity doesn't add any further predictive value. So I thought there must be a way to go beyond lines of code and provide something better and more insightful that's actually actionable. So what I thought was that it's really, really hard to agree what good code is. I mean, if you ask 10 people, you get at least 11 responses.
Yeah.
But it's pretty simple to agree on what bad code is. We can probably agree on a number of things that make code bad. So that's what we do when we calculate code health. We pick up a piece of code. It works at the file level. So we look at individual like classes, modules. And then we stick these 25 probes that we have into each piece of code and pull them out and see what did we detect and how frequent and how deep do the problems go. And then we have algorithms that can weight the finding and classify the code as being good, bad, or in between, in essence.
Yeah, that's interesting. And then this comes back as kind of like a report that you can visualize as well, right?
Yeah, so CodeScene it's a SaaS tool. So you have a dashboard where you can see all your findings. You can see aggregated KPIs. You can get reports. But CodeScene is also quite heavy on visualizations, because if we can visualize things, then the human brain is really, really good at detecting patterns in visualizations. So we include visualizations of the complete code base. So think about it as a map over your code. We see every single piece of code, and it's indicated via colors, like red, orange, green, how healthy it is. And then we do the same thing with the hotspots. So you can also see, okay, yeah, I have some unhealthy code, but this is code that's actually impacting us. Are we working there? So the visualizations, I would say, are a big part of CodeScene.
Yeah, because I remember you had a presentation and you have written a book, right, as well, with the same title, like Your Code as a Crime Scene.
Yeah.
Can you tell me a bit more about the book?
Yeah, sure. So the book actually predates CodeScene. So the book grew out of my experience. I mean, before CodeScene and before the book, I used to be a software consultant. So I worked for lots of different companies, large product companies, and very often I took on some kind of technical leadership role, like a software architect or tech lead, something like that. And in that role, what I found was that I very often end up in the crossfire between the engineering department and the management, right? Management pushing for more features faster. And the engineers trying to push back and say, hey, we cannot do this. This code is a mess. And I found it really, really hard to be that communication bridge because, let's be honest about this. Source code is so complicated that even we as developers struggle with understanding it, right? And how can we expect someone that's maybe non-technical that have never written code in their life, how can we expect them to understand what we as developers mean when we say that code is a mess or it's high on cyclomatic complexity or whatever? So we needed some kind of shared understanding. So that's where I started to look at ways to visualize code and ways to measure and classify code. So I started to do this. I wrote a bunch of scripts and I had my own tooling, and I only intended them to be used for my own consulting. So I used them for the companies I worked for. And I quickly found that, using a hotspot visualization, I could have conversations with managers and explain why we need to take a step back and refactor some code before we can push ahead with this feature in that area. But I also quickly found that it helped me a lot with the engineering team, because now suddenly we as engineers could agree around the priorities that, maybe the thing we thought was urgent isn't really. Maybe our hotspots are elsewhere. So we could get this objective shared situation awareness, and that I think is useful. So after using that for a couple of years, I wanted to share my findings with the community. So that's when I started to write Your Code is a Crime Scene, which came out in 2014, if I remember correctly.
Oh, it's like more than 10 years ago. Time flies. But I think you touched upon something very interesting there. Like you said, you found yourself sort of like as a like emissary between the developers and management. I mean, in my experience, a lot of the issues with technical debt is not like really the depth itself, or like the actual technical issues. It's more like there's usually a lot of like soft issues involved as well, like issues of prioritization, for example, like management wanting to push out new features. Maybe they're not seeing the issues in the code base that's slowing down the velocity. And I guess on the development side, there's the opposite problem. Like, I mean, you and I, we're both developers. We know that we can get a bit myopic sometimes. Like if you see a piece of code and like, this is really ugly. Like I really want to go in and fix that. So maybe management is not sensitive enough to technical debt, and maybe developers are too sensitive. Or what's your take on like the kind of the psychology or the like those kinds of like softer issues around technical debt?
Technical debt is very much I would say a people problem, and you mentioned it. It's a lot of it has to do with priorities, and the reason it's so hard to sell technical debt remediations, it's really, really hard for me as a developer to come to a manager and say, hey, to my product people and say, hey, all these features that you promised our super important customers, you have to put them on ice while we spend 3 months rewriting some code. You won't see any observable difference compared to what the product looked like before. It's a really hard sell, and that's because a new feature has an immediate value. For example, a new feature could open a new market. It could land you a new customer. Whereas technical debt remediations lack an immediate and obvious value. So that's something we have been working on a lot, to connect technical debt to a business impact. And only by doing that, only so do I think that we can close this communication gap between engineering and management and product.
And because, this is a bit of a hobby horse of mine. I remember I read a lot about lean manufacturing like a few years ago. Like back when lean startup was like a kind of a hot thing. I went back and read a lot of those like the original Toyota production system books. And something I found very interesting is that it feels like in the manufacturing industry, they have sort of come around to this idea that, in order to go, or maybe a better way to put it is, slow is smooth, smooth is fast, kind of. Like, in order to go fast, maybe you have to slow down sometimes. It feels like we haven't really adopted that mindset in software for some reason. Do you have any idea of why why that is?
Yeah, I do. I think there's a big difference, and the big difference is that if we look at lean manufacturing, that pretty much grew out of Toyota production system, right? If you produce a car and the car leaves the production line with only 3 tires, it's obvious to everyone that it's flawed, that it has a defect. Software lacks visibility. It's ridiculously hard for us as developers to understand large and complicated systems, and modern systems are like millions of lines of code. Shorter if you do Clojure, of course, but still, there are a lot. And non-technical people, to them, IT is really just a black box. So that's our mission at CodeScene, to bring this visibility to code, to make these flaws obvious as in the physical world.
Yeah, because that was gonna be my next question. Like, let's say you put yourself in the shoes of a developer, and I want to sort of like sell my manager on the idea of either CodeScene or like taking that technical debt seriously. Like, what should I do?
So what I would recommend, and I'm obviously a bit biased here in this conversation, is that I would recommend that you check out our white paper called Code Red, the business impact of code quality. So what we do there is that we summarize our research that we have been doing. And what we found in that research is that if you look at the code health scale, you can basically, I'm oversimplifying a bit, but you can basically split code into healthy and unhealthy. And what we have done is that we have established a link to outcomes. So we know that if you have unhealthy code, then you will be 10x slower with any feature changes, any new implementation, compared to a potential competitor with healthy code. We have also established a link to correctness, to production defects, and have shown that if you have unhealthy code, you have 15 times as many defects. So what's so interesting with this is that it allows you to make the business case for refactoring. So if you find a hotspot, so you know that it's relevant, then you can show that. You can actually bring up this code health and hotspot visualization map, show that to a manager and tell them that, you see this piece of code. We have been doing 50 commits over the past year. We have changed that code 50 times. Each time we do that, we're 10 times as slow as we could be, and we have increased the defect risk massively. If you give us 2 weeks, we're going to fix this, make this code healthy, which means that all these 5 features that you have lined up for that area of the code will be implemented 10 times as fast as you're used to. And that, I think, is quite powerful.
And I guess even if the manager, like you said, like the code is a black box, but if the developers say like, okay, we can reduce the technical debt, then at least the manager can see in CodeScene that something did happen after like 2 weeks. It wasn't just like nothing happening for like this whole time.
No, that's correct. And transparency is really, really important here, because I know from the other, as a startup founder, I know how important it is with speed to market, right? I know how important it can be to have the right feature set at the right time. So what we want to do in CodeScene is that we're not only want to show the code side. That's like the leading indicators of performance. We also want to show the outcome, the lagging metrics. So in CodeScene, you have a second module that you can connect, which shows you the actual delivery outcomes. So there you can see trends in how long does it take you to implement a typical task. How many defects do you have? What are your lead times? And that means that if you act upon this data, then as a manager, I can actually log in and see that, yes, indeed, we became faster. Or we reduced the amount of defects that we ship to production, which means happier customers. So it's possible to have these conversations now.
Yeah, that's really cool, because I think that's one of the things that are kind of like lacking. Unfortunately, I think the state of the art is that a lot of the organizations, they don't even know what kind of like flow, like outgoing flow of features that they have. So even if it was improved, they wouldn't necessarily notice, other than maybe a general feeling of increased well-being, like less stress or something like that. But that sounds really cool. And speaking of papers, like before we recorded, you mentioned that you had just put out like a new paper like related to AI.
Yeah, that's correct. It's a brand new paper. It's a research paper, but we have written it up as a white paper too. That's a bit more accessible. But what we wanted to look at is what we call AI-friendly code. So the thing with AI is that it's we all know it's severely overhyped, and that means that there's a lot of pressure on organizations to implement and adopt AI coding. And I keep hearing enterprises that fail brutally with it, but also see enterprises that succeed and indeed increase their productivity with AI. And I always thought that technical debt management and code quality maturity is going to be part of that equation. So what we did in this paper was that we looked at how good, or rather, what's the break rate? That is the risk that AI introduces a problem. What's the AI break rate depending on the code health? And what we found is that, I mean, on AI always hallucinates. We know that, right? But they do a pretty good job in healthy code. The moment you leave the healthy space, AI error rates increase with 30%. So that's, to me, is really, really interesting because it means we have this metric, we have this visualization that can help you adopt AI agents safely. So if you pick up a code health visualization, it's no longer about just waste. It's actually an important part of AI readiness. So if you look at that map and you see that, okay, here's a green part of the code base, right? That means that that's a part where you can safely adopt AI agents and benefit from the speed with quality. And then you might have other parts of the system that are unhealthy. And that's a part of the code that an AI agent will fail on, and it will fail brutally. So it would just be wasteful to attempt to use AI. Rather, you have to kind of remediate the technical debt first before you can adopt AI. Did I manage to explain that?
Yeah. No, but I think this is really interesting, like especially the fact that this feels like another area where the LLMs, they are like they're very similar to humans in like just the way that they sort of do their best work when they have the same, like the preconditions are the same for doing good work for humans, like when the specs are clear, when there are tests that sort of can guide the implementation, etc. But now it sounds like they also thrive with healthy code.
Yeah, it's very interesting because code health, as I mentioned earlier, it's very much designed to identify code that's hard to understand for a human. But it turns out that code is hard to understand for an LLM as well. So machines do get confused by the same patterns that confuse humans, which is interesting. Perhaps not that unexpected, but now we have the data to prove it.
That's very cool. I'll make sure to link to the paper in the show notes. It makes me think, I think it was like, an Isaac Asimov novel or something where like they don't have like computer programmers, they have like robot psychologists that sort of do like psychoanalysis on the machine because they are too complex to program with explicit instructions. So instead you have sort of like a machine therapy, and it I don't know, it does feel sometimes like people treat they're sort of acting as like like a psychologist or sort of like what do you call it, like a success coach to their Claude code. They go like, you are an expert developer, you make no mistakes.
Yeah, that's partially visual thinking, but there's also a lot of important truth to it, because I think the key to succeed with AI-assisted coding is to double down on all the good engineering principles that we also know about. With AI, everything I've seen, all the research I've seen, is that we need to do more of everything rather than less of it, right? So, yeah, test-driven development, absolutely essential, I would say, with AI. We need to turn the engineering dials to 11 to use them safely and effectively.
So you're thinking almost more like it's gonna instead of like getting like more Wild West, it's gonna be more and more like an operating room theater where you sort of like have these checklists and very strong strong engineering process maybe.
Yeah, I think, I mean, it's a bit of a sidetrack and no one really knows where we will end up. But if I can speculate a bit, I think that the future of the developer role would be more like a team lead, more like a tech lead, right? where the AI and maybe a few other humans make up our team, right? Our collaborators. But to me, working with AI agents is very close to a tech lead role, right? Where I need to, give very precise instructions in some cases. In other cases, can be more relaxed because I know that my team can pull it off. And I also need to kind of be responsible for the outcome, right? And maybe I spend more time reviewing stuff than writing things in the first place. It's going to be really, really challenging. But I do think that we have the components we need to pull it off. But we need to take things like technical depth and strong software engineering principles really, really seriously. I think that's going to be the difference because I think actually that AI will create a divide there where some companies will truly thrive and others will fail brutally because AI will be an amplifier, amplifying both the good and the bad.
So you're thinking of it sort of like, I don't know, maybe like the transitioning to using open source, like a lot of open source technologies or something like that.
Yeah, maybe. I mean, open source is it's interesting. I always used to think that was the biggest productivity gain ever, right? Because you look at the typical enterprise code base today, and 80% of it is based on open source, right? So that's code that we no longer have to write. And I think that, yes, maybe the role of a software developer could be close to the maintainer on an open source project.
Yeah. I mean, it definitely has that same feel as like, this thing where all of a sudden people started pulling down like dependencies instead of writing code by hand. I guess like, the AI workflow is quite similar to that in a sense.
Yeah, I think the key difference is that with open source, we tend to use it a lot for like the infrastructure and the foundation, the frameworks for our application, right? But the core business logic is something that we always used to write ourselves. But now with AI, even that is challenged, right? Because the AI will be writing our business logic, whether we like it or not. That's the way it seems to go.
And like, speaking of being like a therapist for your LLM, like did your psychology degree help you with like, become a better software engineer or like in the development of CodeScene?
Yeah, I definitely think it did. I mean, the reason I went into psychology was because I was interested to figure out why it's so hard to write good code.
Oh, really? Was that like the original?
Yeah. It was many years ago. I worked for some large product companies early on in my career, and I kind of tended to see one software disaster after another. And I was young, I was naive, and I was a bit surprised because there were so many highly educated and skilled people, and yet software seemed to be too hard for us. So that's why I decided to pick up psychology. And originally, I just wanted to do like an introductory semester just to get an understanding of it. But psychology is so fun, so I ended up spending 6 years. And
really?
Yeah.
Wow.
Yeah, I ended up with a master degree, more or less by accident.
So you really like went deep into the jungle.
Yeah, I have that tendency. Yes.
But okay, so I mean, if we go down into a bit more detail, like what were some of the questions that you went in hoping to answer? Like, did you have any specific ones? Why?
So I think it falls into like two. I mean, psychology, it's a pretty broad discipline, right? But I ended up kind of being mostly interested in two parts: cognitive psychology, which is a lot about how we think, reason, and solve problems. And that proved super relevant to a software developer. And the things I learned there, that's pretty much the knowledge I brought into the code health metric. So the code health metric was very much designed with like the limitations of the human brain in mind. The other part that I became interested in was like the social psychology stuff, like how we collaborate and how we work together, which is something that I think is also partially reflected in the work I've been doing. So if you pick up your code as crime scene, you will see that there are a lot of analyses that aren't about the code as such, but are more about the people organization. Like, do you have things like knowledge islands, large parts of the application absolutely critical that only one developer knows about? So organizational risks like that is something that I've also been interested in.
And did the psychology degree help you answer all of those questions, or are there still ones that are like unresolved?
Yeah, I think I came far, but there are still things I like to understand. And the thing that fascinated me back when it's a long time ago now, but when I studied psychology, we also had a course where we read about or learned about human consciousness and conscious thought, and this very subjective feeling of me. Where does it come from? And it turns out that I'm going to summarize a lot of reading material for you now, but it turns out that no one really knows what consciousness is. No one has any idea whatsoever how it works. And that fascinates me because I keep hearing from Silicon Valley about how close AGI is, right?
Oh, yeah.
But we have no idea how consciousness happens, and the chance that we can build it in silicon is, I think, not really going to happen in our lifetime. But that's my guess.
Yeah. I think this is all, like, everything about this I think is really fascinating, because it feels like there's so many different fields intersecting, like, psychology, and also, like, I always figured, like, programming is also kind of like a bit like practical philosophy in a way, in that it sort of like lets you express like completely unambiguous statements about something.
Yeah.
And like, mathematics, I don't know, it's just and like you said, it's like different aspects of psychology as well, like cognitive psychology, and like how we interact as a group, etc. There's lots of interesting stuff there, I think.
Yeah, and I think it's also, this is a podcast about functional programming too, right? So I think that's also my psychology background also explains my love for functional programming, because one of the key ideas behind human problem solving is that we start with an imperfect understanding of the problem. Then we try to express it as a solution, which in our case means code. And then we observe the outcomes and we learn from that. And then we refine our understanding of the problem and reflect that in the next iteration of solution. So human problem solving is inherently iterative. And that's very much what attracted me to FP, that, with the REPL, I can get exactly this workflow, right? Where I can iterate, refine, learn, experiment. So I think FP is really one of the keys to get the most out of our, let's be fair, limited brain power.
Okay, so like you're saying with the REPL, you can sort of get this workflow where you have like an hypothesis first, and then you do an experiment, and then you can sort of either reject or validate the hypothesis.
Yeah, that's exactly. And before I even started with FP languages, I was quite an early adopter of test-driven development. I started doing that like almost 25 years ago. Okay. I stumbled upon it in a news group and got fascinated. And what I liked about it, even though if I couldn't really articulate that back then, but I very much like this interactivity that you can partially mimic with test-driven development, right? Even in say, compiled object-oriented language. But the feedback loops are longer, and it's not as you cannot just, go in and start to run random code, right? You have to do a lot of work to get that interactivity.
Yeah.
But I do think it's the feeling I get with REPL is like test-driven development on steroids.
So yeah, you get you can close the loop very, very quickly.
Yeah.
But speaking of which, like, how did you get into Lisp?
Oh, that was also many years ago. I read an essay by Paul Graham called "Beating the Averages."
Oh, yeah, that's a classic. I think that was the one that got me too.
Yeah, I think it's responsible for a lot of Lisp programmers. And back then I found it fascinating, but I also kind of doubted it, because what Graham basically says is that using Lisp allowed them to outcode all their competitors, right? So I thought this sounds too good to be true, but I got interested enough to start to learn Common Lisp. So I started to learn that. I think that was a little bit more than 20 years ago. It took me a while, because at that time I was already considering myself a fairly experienced programmer, but I found that Lisp is so different that I had to kind of rethink everything. So it was very challenging. But once I got it, then I never looked back. I really, really liked it. And when Clojure came out a couple of years later, then I thought this is a perfect fit, because Clojure, being on a JVM, solved a lot of the problems I have with Common Lisp, and that was that Common Lisp, the language, I really love, but the community is so small that you often find that you're struggling with finding the right libraries or whatever challenge you have. And Clojure, being on JVM, suddenly had access to the vast amount of Java software. So to me, it was Clojure was really godsend.
So, but what languages had you tried before, or what were you working in before you found Common Lisp?
So I started out doing a lot of assembly code, C code, low-level stuff, and did a lot of C++. C++ is probably the language I used the most after Clojure. But I also did a lot of consultancy gigs using Java and .NET and some Python. And when it comes to FP, the only other language I learned Lisp first and Clojure, and then I was fortunate enough to do a project in Erlang, which I really love too. So that's a bit of my background.
Yeah. So what was the thing, what was the biggest difference in your mind, when you came from C++ and then you came to Common Lisp? Do you remember what were some what was the biggest, the most important differences, you think?
I mean, there were a couple of habits that I quickly had to unlearn that really held me back early on. I think the first one was the whole concept of immutability. I really, really struggle with that, because if you come from a background with C and C++, you're quite used to, you mutate stuff. That's how you make changes. That's the whole essence of object orientation as well, right?
Yeah.
That was the first challenge. The other one was it was a bit simpler for me, but still I struggle a bit as well with higher level functions. Because and I think it's unfortunate, because it's a learned difference that functions are somehow different from other types of data, right? And so that it's a couple of habits that I had to unlearn.
Yeah, there are some subtleties with them as well, how closures work and how they capture the environment. And in Common Lisp, there are different namespaces as well for functions and values. Or did I get that wrong? Maybe there's a difference between Lisp 1 and Lisp 2 Lisps, right?
Yeah, there are differences. So if you look at Scheme and Common Lisp, they behave differently with respect to closures. But I think higher order functions was a bit easier, because I could, use a mental model for object orientation, right? It's a little bit you package an object, it has some data, and it has just a single function. So it's very close to some design patterns I was familiar with, the command pattern, for example. But still, to learn to truly design with functions, that took a long time. And 20 years later, I'm still not sure that I fully get it, but it's better.
Yeah. Yeah, I mean, it's very powerful. I mean, there's this classic, I don't know if you've seen that. I think it was Peter Norvig who had a bunch of slides where he takes pretty much all of the Gang of Four patterns and says oh, this is just higher order functions. This is just higher order functions.
That's a beautiful presentation. I really love it. I mean, I remember in my C++ days, I spent a lot of time trying to understand the visitor pattern, right? Where you can do dispatch on multiple dynamic types. And it's extremely painful to implement in an object-oriented language. And it's it causes a very fragile design, hard to change, hard to extend. And then you learn about multi-methods in Common Lisp or Clojure, and you realize that, this is the way to do it. This is how you model that specific problem.
Yeah. It's much simpler. Don't have to sort of I don't know, contort yourself too much to fix that. But so when you started building CodeScene, was it obvious that you're going to build it in Clojure, or was there some was there still some like hesitation, like some other, or did tell me more about that.
Yeah. So Clojure to me, that was a given. I knew that I wanted to do Clojure, and I wanted to do it for, I think, 3 different reasons. The first is that, I mean, when I started CodeScene, I was the only programmer, right? So I knew that I have to really, I have to really optimize for productivity here, right? Yeah. And I knew from my hobby projects that I can be much more productive in Clojure. So that was number one. The second reason was that Clojure is really fun. And I think that fun is a much underestimated driver in software. Fun guarantees that things get done. And I knew that doing a startup will be like 70, 80 hours a week. And it's been that way for many years. So I want to make sure that those hours really count, that I do something I truly enjoy. And the third one was that I had this hunch back then. I have since confirmed that it's correct, but I also had this hunch that Clojure developers tend to be very skilled engineers, right? Quite often they're a self-selected bunch. It's people that usually started doing something else and started to explore Clojure in the spare time. Which to me is a very good sign that someone cares deeply about what they do and care deeply about programming. So I think the Clojure community is also excellent. So those are like the 3 main pillars.
That's very interesting. Yeah. Oh, sorry, you were saying?
Yeah, no, that said, I had some initial thoughts around, I've been doing quite a lot of Erlang the years leading up to CodeScene. And I always thought that, Clojure, it's great at a lot of things, but I always thought that maybe I could use Erlang as like the platform, right? And then I spin up Clojure processes. But I even have a prototype for it, but I quickly realized, but I quickly realized that, it might be hard enough to use one niche technology, right?
Yeah.
The intersection of people who know Clojure and Erlang is not that big, so.
No. But have you seen Robert Weirding's Lisp-flavored Erlang?
Yeah. Many years ago, yes. That's it's really cool.
Maybe that could have been an option. But I see where you're coming from. It's like, it's a niche language already. Like, no need to double down. But did you ever have any doubts whether, like, I wonder if this is going to work? Like, are there any like drawbacks with Clojure that sort of worried you initially?
Yeah, what I was worried about initially was performance. So I wasn't sure because CodeScene is processing a lot of data. I don't know, think about a large enterprise code base, maybe 20, 30 million lines of code. You have to scan all that data. And you have to scan all the Git history, and you have to scan all their Jira tickets or whatnot, right? It's a lot of data processing. And I was worried about performance. I thought the Clojure being dynamically typed and all of that, it's not going to be fast enough. But I kind of always thought that, I could use Java as like the assembly language of the JVM if needed.
Because you could fall back to that if you
I could. And I could even write parts of it in, I don't know, C++ or whatever. But it turns out that didn't really happen. It has never been a problem. Because what I think Clojure does so well is that it allows you to truly think about the data, and it allows you to truly think about the algorithms. And the most impactful optimizations are always at algorithmic level. So 10 years later, it never really became an issue with performance. I'm really happy that I choose Clojure.
That's interesting. I also find it interesting that you mentioned the hiring pool as a plus, like a positive of picking Clojure, because a lot of the time when it comes to like niche technologies, people are hesitant because like, maybe I won't be able to find developers, etc. Like maybe I can't get enough help, maybe the community is too small, etc. But that doesn't seem like it was your experience.
No, not at all. I never had problems finding really skilled people that want to work with Clojure. But I heard similar concerns. So very early on, when the company was just starting, to land the first customers, I spoke to a couple of investors, and the ones that asked me about what languages have you used, what technologies, and when I told them about Clojure, they have of course never heard about it before. So I tried to motivate it with, the productivity benefits and whatnot, and they said that, hey, you should rewrite everything in Java, because if you do, I can hire you 10 developers tomorrow. And I always thought, I don't want 10 developers, I want maybe 2, 3 that know what they are doing, right?
Yeah.
Because there's so much coordination overhead with the larger team, and that I think is the big advantage of these languages, that they allow you to get more done with a smaller group of people that also limit like the organizational overhead, and that I think is valuable.
Yeah, I mean that's a really good point, I think. And I mean there's a classic example of like WhatsApp, and I think it's like $1 billion company, and they're just like, I don't know, I think there's still like 20-30 engineers building the product in Erlang. So I mean it does allow you to be like stay productive, I guess. And I mean you mentioned Erlang as well, but if you, let's say you couldn't use Clojure for some reason, Rich Hickey comes out and says like, no, Clojure is closed source now, it's a commercial product, you have to pay a license or something. Like, would you, what other language would you pick to write CodeScene in?
Oh, then I would most likely have gone with, and this might be a surprise, but I would most likely have picked Python.
Oh, okay. Why Python?
I have this sweet spot for it. It's always been like my second favorite language, and I still tend to do a lot of stuff in Python. And the reason is, first of all, I think the language itself, I mean, it has grown more complicated in recent years, but it's still, I think, quite brain-friendly. It's like fairly easy to read Python code, and it's I like the feeling of writing it. And there's also an extremely strong ecosystem for data analysis in Python. So I think that could have been a good fit as well.
Yeah, what was that word used? Brain-friendly?
Yeah.
Yeah, I think that's a neat way to put it. I think it is very like it is kind of like Lisp-ish, I guess, in some ways. In that like it's not, at least it like the Python from way back. Like you said, now it feels like it's getting more and more complicated every year. But back in the day, at least, it felt like it had kind of like that like scheme essence, that it was supposed to be very simple. And I don't know, if you use the IPython, it's I would say it's pretty close to like having a REPL experience. Yeah. And you have the notebooks and everything.
Yeah, it definitely is, and a super strong ecosystem. So I really like that. And of course, there are a couple of things I try to ignore when doing Python, like the whole object-oriented additions and that stuff.
Yeah. I mean, you can use just like use functional programming and use dictionaries, etc. But like when it comes, like speaking of programming languages, like what makes Clojure stick out among the other programming languages available today, you think?
So I think, I mean, there are so many things that Clojure kind of pioneered in the, maybe not mainstream, but close to the mainstream of programming. Like the whole idea with immutable data structures that are still efficient. And what I like about Clojure is that it really, really forces me to do to embrace immutability. That I think is the biggest win. What I also like is that Clojure kind of encourages this, like, what do you call it? Like this railway style of coding, right? With threading macros. We simply chain together whatever functions you like, and can compose those into higher level abstractions. So I think that
stuff forward like all the time.
Yeah. It's a lot of it is about getting your data structures right, and then the algorithms are dead simple, right? It's a bunch of map, filter, and reduce, and you're done. And then you put a good name on it. So what I really like is that I have to write so little code to test something out. And that I think is one of the big benefits. With 10 years of hindsight of using this in production, another benefit is that the language has remained remarkably stable. There have been virtually no changes to the core language in 10 years, right? No new syntax. So it's like the opposite of where Python went, right? Clojure was very, very carefully designed, and I haven't felt anything lacking. And should I feel the need for any extensions, then I can implement them myself, thanks to the macro system of Lisp, right? So those two together, I think, are invaluable.
Yeah, so, and I mean, speaking of like using Clojure in production, are there any other like benefits you think to using Clojure like in a production setting?
I think Clojure excels on the development side. I think in production, I mean, then we come into one of the drawbacks of Clojure, and that I think is the whole error handling with the stack traces. The Clojure is extremely high level as a language, but once something goes wrong, that whole abstraction just breaks down, and you're exposed to all these layers of implementation in between. And of course, it's a learnable skill, right? After a couple of months with Clojure, you become quite good at reading these stack traces, but it's not super friendly, and it's definitely a leaky abstraction, I would say.
Yeah, I mean, it was a while since I did Clojure, but I remember those. You get like, it goes all the way down to like the Java class layers.
Yeah,
right?
yeah. And a lot of generated code in between and whatnot. It's really, really hard to parse at first.
Yeah, but at least it usually points to the right place in the file. If you read somewhere in the middle, right? Or is that also hard to like find what actual like line in the file?
No, it's pretty straightforward, and you become used to it. This becomes like almost an unconscious skill, right? You do more or less like a binary search of your stack trace. Was it here? No, it's there.
Yeah. Yeah, I mean, I remember when I started using Erlang, they didn't even have stack traces. So that's definite improvement, I would say.
Yeah, I mean, the whole error handling in Erlang is it's a marvel of engineering. It's one of the most beautiful things we have in software, I think.
Yeah, Erlang is really cool for like resilience and things like that. But I mean, Clojure is not is pretty strong with like async, parallel programming with the core async library, etc.
Yeah, it definitely is, and those are really, really good. I mean, that's one of the things I talked earlier about, my concern of performance, right? But Clojure, being immutable at its core, makes it so easy to parallelize stuff. So, for example, I mean, in the first implementation I did for when we calculate code health, then I simply scanned through every single file sequentially, and that took forever, right?
Yeah.
And then with Clojure, it was like a 5-minute fix, or maybe even less, maybe just a minute, right, to make all of those calculations run in parallel and simply fan out on whatever CPU cores I had available. And I couldn't even imagine doing that in, say, C++ or any other language with mutations, right?
Yeah.
It would be a nightmare.
So you got like 2-week rewrite instead of like a 2-minute fix.
Yeah, and two months debugging.
Yeah. But are there any like other things that you don't like about Clojure, like either from like an operational perspective or just like personally?
I think it's like a combination of operational and personal. That what I would really, really like to have is a good optional static type system. Because I have found that, Clojure being a dynamical type language, it's very, very powerful because it lets you explore and evaluate IDs very quickly without bothering about types. But then the thing is that after a while, your solution starts to stabilize. And it would be really, really nice if I could go in and kind of sprinkle types on top of it, right? It would help a lot with understanding the code. So that's what I think is one of the big benefits of static type system, that the types communicate a lot about your data. And in Clojure, this can be much, much harder because, you have a map, a dictionary, and it could basically be anything in that bag. So I would like to be able to have that combination. And I think it was like 8-9 years ago, there was a pretty big drive behind Clojure spec, if you remember that.
Yeah.
And initially, that was a little bit my promise that, now I can get the best of two worlds, right? I can do dynamical type programming, and then I can add types as documentation and have them checked at runtime and whatnot. But spec, I think, never really lived up to its promise. We're not using it. We're using it a bit, but not as much as I would have hoped.
Okay. So, and what was were the issues with, like, I mean, the obvious one is that it's like, that Clojure is not compiled, that like the spec thing, it exists at runtime. I guess that's one thing. But were there any other issues with spec?
I think that's definitely the biggest drawback, that it's a very late detection if you violate your own specs. But I also found like the format of the specs themselves made it quite hard to use them as documentation.
They're macros, right?
Yeah, it quickly becomes too complicated, right? So when you sit there with a function, even if it has a spec on it, it's quite hard to decipher what the data actually is. So I think like a regular static type system would have gone a long way. But,
yeah, like, I think that's like that's the thing I really like about static typing as well, is that usually, like, once you're in the right function, you usually don't need to, look anywhere else in the code, like, because like, okay, I know what's coming in, I know what I'm supposed to produce, so I can just stay here within these couple of lines. But as soon as I've had some really bad experiences working in large dynamically typed code bases where maybe people weren't maybe as disciplined about what code, like what data goes in and what goes out. So you kind of like, you have this user object coming in and you need to maybe access an email property and like, oh, will this always be available? Maybe not. Like, is it a string? Is it a map where the email is kind of like taken apart into domain and like username, etc. Yeah, I mean that whole thing becomes a bit much more difficult, I think.
Yeah, I agree upon that. And that's the thing. That's to me the biggest advantage with static typing. In addition to the performance boost and all of that, you have the full context for every single function, and that's super valuable. It's a big part of the documentation, I would say, the type system. On the other hand, most of the code bases I look at in an enterprise setting, they are statically typed, but 80% of all the arguments are strings. So I'm not sure how much you gain in practice.
Yeah, but I'm spoiled because I usually like I spend most of my time nowadays coding in F#, and then it's very, very easy to create like these very specific types, like. But I agree. Sometimes, like it's when you have a method and like all of the arguments are like string, like okay, what was the point of this again? It's like, but have you tried any of the like alternatives to spec? I mean, I know there's Mavli, for example, and there was this other thing, which I don't remember the name of, but it was an effort to like sort of put a proper like a static type system that could analyze things statically, but I'm blanking on the name, unfortunately.
No, I haven't. My colleagues have been playing around with that stuff, but eventually what we ended up with was that we had to more or less double down on discipline, right? So you can compensate for the lack of static typing by being extra diligent with your unit tests. They become really, really important as part of the documentation, right? And then also about encapsulating stuff and keeping our our modules, our namespaces as small as possible. That also helps a lot. Okay, so I think today I'm less worried about that than I used to be when I started up with Clojure.
Okay, so I mean it kind of like it's a drawback, but you can kind of work around it.
Yeah, I would say so, definitely. Yeah. It hasn't been holding us back, but it would definitely have been nice to have maybe a little bit more as the code base grows. I mean, for a small code base, it doesn't really matter, but I mean, Clojure CodeScene has been around for 10 years now, so it's a relatively large code base, maybe the largest Clojure code base in existence. I don't know.
Okay, sorry, how many lines of code do you think it is, roughly?
I don't know. In Clojure, I would guess it's definitely a couple of hundreds or thousands of lines of Clojure code.
Yeah, that's pretty big.
Yeah, it's like 20 million lines of Java probably, the equivalent.
But do you have any other tips for managing a big dynamically typed code base? Test coverage was one thing, modularizing, but do you have any more?
Yeah, I think we need to use the tools that we have available, right? So I think aiming for not only a strong code coverage, but also a meaningful code coverage means that you need to spend a lot of time reviewing your test cases, make sure they are maintainable, understandable too. But we're also using a lot of linting tools and stuff like that. But I do think that tests are the single most important property for us. It's really the enabler that allows us to move fast, and we try to use tests at least 3 different levels. So a lot of the stuff we do is test driven. So we have a pretty strong unit test suites, and then we always do some integration tests, and finally we have some end-to-end tests, and some of these end-to-end tests are even executed in production.
Oh, okay. Yeah, so you sort of get a really good, maybe triple coverage in some cases.
Yeah, and I think that's absolutely necessary because a modern software product is so complicated. There are so many layers, and the reason we do a lot of testing in production too is because we have all these integrations with, say, the version control providers like GitHub and GitLab and whatnot. And every now and then there's an issue with their API, right? And that's something that we cannot really test. We have integration tests, but they are kind of based on an expected contract, and that might change, or there might be a bug in an external API, and that we can only catch in production.
Yeah, and even then, type system won't save you then if someone
no,
violates
it won't.
Violates the contract. Do you have any other, since you have such a big Clojure code base, do you have any other advice or things you have learned, managing this this large Clojure code base? Any lessons learned along the way?
Yeah, I think it's 2 things. I think first of all, good naming is so important, and maybe even more so with the dynamically typed language. So I really want to be able to pick up that code base and be able to, immediately identify what do I need to change if I'm looking to modify something. So naming at the subsystem level, at the namespace level, file level, function level, that is really, really important, and I do spend a lot of time thinking about that stuff. The second thing that I think is really, really a success factor, that's the skill of the team. So with a really, really strong team, I think you can succeed no matter what programming language you choose.
Yeah, I guess that's a good takeaway. I think that in the end, it's not the tool; it's the person using the tool, right?
It is, and the tool can it can hold you back, or it can become an amplifier. Clojure is an amplifier, and it's a sharp tool, right? So in the hands of skilled people, you can make wonders with it.
And when it comes to naming, do you use any kind of domain-driven design techniques to sort of organize the code base and name things, or how do you think about naming and organizing things?
Yeah, I'm quite a big fan of domain-driven design, so I always like to see domain concepts. And if I look at the file names, I want to see domain concepts reflected, not necessarily solution terminology. And I think I got most of the way I think about naming, I got a lot of influence from a really good book, Kent Beck's first book, that I think few people have read it today, but it's called Smalltalk Best Practices.
Is that the one with the flies on it? Or maybe that's the first edition.
Yeah, might be. It's an old book. I think it's from the 1990s, mid 1990s. Was before XP and all that stuff.
Yeah.
But it's a
I've
really
heard
good.
about that. As far as I remember, it has a really really weird looking cover as well. But I've heard lots of good things about it. Okay, but
Yeah,
that book taught you about naming and.
That book, I think that's the hallmark of a good book, that it changes the way you actually program. And back when I read that book, I was doing consulting as a C# developer.
Oh, okay.
And I kind of found that, okay, when I read that book, I kind of changed how I name functions, right? I started to think about them in a different way. I started to name them not based on what the function does in itself, but rather what does it look like in the calling context. So I try to aim to, get my code lined up as like descriptive sentences that can guide you as a developer. So that's pretty much the pattern we've been following at CodeScene too.
Yeah, so it should be like sort of optimized for what you say, like for what the function is supposed to do in the context rather than what's inside it, or.
Yeah, something like that, right? So always when I name the function, I name it from how I'm using it.
So did you ever get to program any Smalltalk, or?
I mean, I did, not in a professional setting, but I did learn Smalltalk. I read a couple of books about it, did some projects in it just for my own learning. And it's a pretty cool way to think about programming.
Yeah. I mean, Smalltalk is very, very impressive. There are a lot of touch points with Erlang as well. I've never used it myself actually, but it's very, very cool concept. But I like that idea that you can learn so much not related to Smalltalk from a book on Smalltalk. I remember one of the books that had a huge influence on me when I was earlier in my programming career was a book, like a Perl book by Damien Conway. I think it was called Perl Best Practices. Even though I'm not writing any Perl right now, and I only write maybe I wrote like a couple of hundred lines of Perl in my entire career. But maybe there's a pattern here that if you have a book of best practices, I guess a lot of those, they sort of transcend the language that the book is written for.
Yeah, I think so. I think there are some universal truths about what makes good code that apply to almost all languages.
Yeah, I guess that also loops back to the whole cognitive psychology thing as well. But I mean, speaking of best practices and stuff, do you organize the code in any specific way, or do you use any I know there's the Polylith framework, for example, for Clojure. Do you use that or something similar, or how is the code? How is the code organized?
No, we never used any frameworks. I don't know. I have this almost allergic reaction to frameworks. So I always try to avoid them. And we try to keep things very, very simple. So a lot of it is vanilla Clojure. Of course, we use frameworks in small parts of the code base. I don't know, it's implementing HTTP requests. It's pointless to do that on our own, right? So let's use what's already there. But otherwise, we try to organize it according to domain and responsibilities. So if you pick up the folder structure of, say, CodeScene's core analysis library, then the names of these folders that you see, they will reflect things that you also see in the UI.
Okay. So it sort of mirrors the way the product works, kind of, or?
Yeah, not fully, but to some degree. So the high-level folder names, they're all domain concepts.
I see. But are there any other important libraries that you use in the CodeScene code base? Because I know there are a lot of you can do so much with Clojure, right? You can sort of add a kind of a prologue-like language if you use core logic. There are a lot of really cool libraries for working with data, for example. Are there any core libraries that you leverage or any packages or libraries that you leverage heavily in CodeScene?
Yeah, there are tons of them. And I mean, if you would ask my colleagues, you'd probably get different answers. I'm a bit biased with the parts I tend to maintain. But some core libraries to me it's a simple library, but I really love it. It's semantic CSV that makes it super simple to work with CSV files.
Okay.
So I really, really like that library. It saves me so much pain. And then I'm also doing a lot of work with parsing source code. So that means I'm relying heavily on tools like Antler and Tree Sitter, those type of tools. And also, I mean, it's such a productivity boost using these tools and libraries compared to, say, 30 years ago when I wrote my first parsers in Lex and Yak.
Yeah. Can you tell me a bit more about the semantic CSV thing?
Yeah, that's the nice thing. There's not so much to tell about it, and that's what I really like. So we have a lot of our data sets are organized as CSV files. And semantic CSV, you simply point it to a CSV and you get back a Clojure map. And you can even, it's very declarative, so you can basically tell it that, this particular column in your CSV, it's a double with this or that precision, and this is an integer and whatnot. And you basically get the Clojure map back. Mapping Clojure is like a dictionary, and everything is already parsed and resolved for you.
Oh, that's very nice. Yeah, because I mean, parsing CSV is surprisingly complex and
it is
error prone.
Yes.
So, like, if you just think that, what's the big deal? I can just split on commas. Like, you're in for a world of pain.
Yeah.
No, I mean, but I guess that's sort of like the essence of Clojure, right? It's like, it's not trying to do anything fancy. Things should just work. Should let you be productive.
Yeah, and that's what I like so much about it. The language kind of gets out of my way, and I can just focus on solving the actual business problem rather than doing all this meta work around it, right?
Yeah. If someone was to get into Clojure, like in the year 2026, like what would be a good place to start? Like any YouTube videos, or like how should you go about it, you think?
Oh, it's a fantastic question that I don't think I'm capable of answering it. I mean, 10 years ago, I would still have known what a good introductory resource could be. Now, I don't know. It depends a bit on learning style, too. I like to learn from books. So I tend to buy the pragmatic programmer books. I read a bunch of the books they released on Clojure, learned a lot from them. But I'm not really up to date with 2026.
Yeah, but I guess it hasn't changed that much. Like, what's your recommendation for a good Clojure book for maybe both beginner and advanced? Yeah,
I'm trying to remember what books I read back in the day. It's been a while since I read a Clojure book, but I think there was Programming Clojure from the Pragmatic Programmers was a really, really good read. And there's also a book that came out, I think it's fairly recent, called Clojure Brain Teasers.
Okay.
By Alex Miller. That one is, I would say, for advanced Clojure programmers, because, after doing Clojure for more than a decade, there was embarrassingly many of these brain teasers that I couldn't figure out without actually trying them out. So it's I learned a lot from that book, so I think that is a good next step.
Okay, so if you want to if you passed the point of a beginner and you want to sort of elevate your skills a bit, then that could be a good book.
Yeah, I think it's really, really good in pointing out how complicated things can actually be, and a lot of it is the intersection with the JVM.
I've heard a lot of good things about Eric Norman's book, Grokking Simplicity, even though that isn't, I think that book is actually in JavaScript. I think it could sort of help you get into the right mindset for being a productive Clojure programmer, especially if you're more used to I don't know, C++ or whatever, like the classic more like procedural imperative programming style. But have you read that?
No, I haven't read it. It's been on my reading list for quite some time. So thanks for the reminder. I will most likely pick it up now. So I think it's useful because a lot of the, like we talked about earlier, a lot of the skills, I mean, the syntax in Clojure is that simple. You learn that in a day, right? But the hard thing is the mind shift, going from imperative program to functional. So anything that helps with that is useful.
Yeah. There's not much syntax to learn in Clojure. Nearly, like, learn a bunch of different what do you call it, like parentheses and like brackets, and then you're pretty much done, right?
Yeah, the curly and the square brackets, and you're done. That's it.
Yeah, but I mean, and of course, everyone should watch, the rich Hickey talk, the Simple Made Easy talk.
Yeah,
probably the best one of all time.
And then I will also remember, I mean, early on I found myself browsing the API documentation of the core libraries as well, because there are surprisingly many helpful functions that are already implemented for you. And I remember early on in particular, I often found myself that I've been implementing something that I could have been replacing with the library function. And after a while you learn that, but the library is surprisingly complete and large.
Yeah, I remember that, like, the documentation is really well written, like for the just the core, like the core Clojure language and the standard library is, it has a bunch of examples, etc. And it's like, it's a like you said, it's quite nice to just sit down and, like, you can sort of like just read it from top to bottom.
Yeah.
And get a good, like, impression of what's in the library. Yeah, I think we're nearing the end time of the podcast. Like, do you have anything else you would like to add about Clojure or CodeScene?
Yeah, well, I mean, one thing I can add is that everything we talked about before about AI-friendly code and all of that, we want to help you with that. So one thing I've been working on a lot over the past few months is to, together with my team, to build an MCP server that understands code quality and understands code health. So that's something, if you're interested, that might be something to check out, the CodeScene MCP server. It's really, really cool. It can help you safeguard AI and can also elevate the AI performance, right, to an acceptable level where the AI can start to self-correct instead of just adding to the technical debt problem.
Yeah, I was going to ask if you've experimented a bit with that, because a lot of people are saying that if you, like, the AI performs best when you can put it in a feedback loop, so you can sort of, like, it can sort of correct its own mistakes. Does it work with the MCP server?
Yeah, it works really, really well. I have a couple of YouTube videos on it demonstrating it. And I also have a blog post called The Inner Developer Loop that shows and explains it. It's
okay. I'll make sure to add those to the show notes.
Yeah, it feels really, really magical, right? So you see this AI agent go off, and then it kicks on the MCP server, it gets some feedback, it self-corrects, it improves. It works surprisingly well. It feels almost magical.
Yeah, I mean, that sounds really cool, because it's like one of the most annoying things I think when, like, coding with LLMs. It's like, it's one thing to sort of like coach the LLM and sort of sometimes you realize that you gave it ambiguous instructions, or you see something that it wrote and you don't really like the way it looks, etc. I mean, I can accept I don't mind being the human in the loop in those situations. But what really annoys me is, like, when it makes obvious mistakes, sort of like, it sort of copies and pastes code, like almost exact same thing, like a little bit tweaked a little bit, or like when it does just, like obvious things like this. So maybe the CodeScene MCP thing can help with that.
Yeah, it seems really, really promising, because I think what happens once you give, it's all based on the code-off metric, of course, which is validated, right, with this business impact. And we start to inject that into the AI. What happens is that, first of all, the AI gets a goal. It knows what good looks like. And when it fails to meet that goal, it also gets detailed feedback on what it did wrong. So that kind of sets the scene for this self-correction loop.
Are you gonna be integrating like more AI tools into CodeScene itself? Like I'm thinking more on the analysis side.
The analysis, most likely not, because the analysis, I think it's really important that it's deterministic, that we have a ground truth. But what we find is that we do a lot of AI work when it comes to the remediation. So, detecting technical debt and prioritizing it is really just the first step. Now we need to act upon it as an organization, right? And that's where it usually blocks, because, people might lack the skill sets on how do you write the code in a better way, how do you refactor it, or the priorities and time might simply not be there. So that's where I think AI can help a lot. And as an industry, we seem obsessed with writing more code faster. And I simply think it's the wrong problem to solve. I think it's much more important to take the code we already have and uplift it so that not only you as humans, but also your AI agents can safely iterate on it. So there we are finding that we use a lot of AI to uplift and remediate technical debt.
Yeah, because you can have CodeScene identify the technical debt, and then Claude can go and fix it, and then Claude can use CodeScene to fix its own mistakes, and you're golden.
Yeah, something like that.
Yeah. Unless you have anything more to add, I think I'll say, thank you, Adam, so much for coming on the podcast. And, where can people find you? Do you have are you on any of the social medias?
Yeah, I tend to be fairly active on LinkedIn, so you will find Adam Tornhill on LinkedIn, and I'll be happy to connect with anyone interested in code quality, technical depth, functional programming. I love that stuff, so that's where you find me.
Yeah, and and CodeScene, you can find that at codescene.com, I guess.
Yeah.
Yes, and I don't know. Every time I talk to someone who's really into Clojure, I sort of I want to start, get back into Lisp again. It is a lot of fun, and Clojure especially is because it's so pragmatic as well. But we'll see. Hopefully we can get more Lisp people on the podcast as well. But yes, thanks a lot, Adam, for coming on the podcast, and talk to you later.
Yeah, thanks for having me. Take care.